Hey everybody, welcome to Algebra 2, and this is 3.1. This is your ordering email here for PowerPoints, videos, worksheets, tests, quizzes. Alright y'all, 3.1, evaluate nth roots and use rational exponents here. They'll walk you right through this, man. You got 30 points here for your classwork and 18 points for note-taking. There's a lot of note-taking here, y'all. So get your notes out, get your pencil out. This is the bell work, teachers, for your students walking in your classroom at 7:25 in the morning or whatever. Have them do this. This will maybe wake them up, help to wake them up. Otherwise, later in the day, have them warm up with this. Before you evaluate square roots and use properties of exponents, you will evaluate nth roots, and study rational exponents so you can find the radius of a spherical object, as in example 60. Whoa, I think that's in like part 3 of this lesson. You know what I'm saying? Okay, so you can extend the concept of square root to types of roots. For example, 2 is a cube root of 8 because 2 cubed equals 8. In general, for an integer n greater than 1, if b to the nth equals a, then b is an nth root of a. This is pretty fancy here. An nth root of a is written as the nth root of a, that's a fancy thing there, where n is the index. They call that the index of a radical. So this number here, or variable, is called the index. You can also write an nth root of a as the power of a. If you assume the power of a, power property applies to rational exponents. The following is true. So we're going to have a vocab slide here, nth root of a. Students, you can go back and look in your classwork to fill in your notebook. And when I teach this class in a classroom, I check notebooks every Friday. I have a notebook check there, and by gosh, it's worth 10 points. You know what I'm saying? Okay, so we move into a concept slide here. Real nth roots of a, and this is classwork. So this is on your classwork sheet, page 5 of this lesson here, and it's worth 2 points, students. N is an even integer, n is an odd integer, and here are the conditions here for an even integer, and here's the conditions here for when n is an odd integer. A is less than 0, no nth roots. A equals 0, 1 real nth root. Then when a is greater than 0, 2 nth roots. A plus or minus, n to the index of a equals plus or minus a to the 1 minus n. It gets a little formative here, but it's an important classwork sheet for students to take down. Finding nth roots, find the indicated nth roots of a. See, n equals 3 and a equals to the negative 216. Because n equals 3 is odd and a equals to the negative 216, which is less than 0. Negative 216 has 1 real cube root, and it is negative 6. So negative 6 cubed equals negative 216. So this is the way that you write that. The nth root, the cube root of negative 216 equals negative 6, or negative 216 to the 1 over 3 exponent equals negative 6. So we're talking about fractionated exponents. Find the indicated nth root. So we're trying to find n equals 4 when a equals 81. Because n equals 4, a equals 81 is greater than 0. 81 has two real fourth roots. Whoa, you figured it out. You go back in your video. Okay, now find the indicated real nth roots of a. N equals 4, and then a equals 625. Students, you have this for your independent practice. N equals 5, and then a equals 243. So for this situation here, when n equals 4 and a equals 625, because n equals 4 is even and a equals 625 is greater than 0, 625 has two real fourth roots because 5 to the fourth equals 625 and negative 5 to the fourth equals 625. You can write plus or minus, and then here it would be the radical to the fourth index equals plus or minus 5, or plus or minus 625 to the 1/4 root, which is this, equals plus or minus 5. Here it is on a calculator. Rational exponents, rational exponents. Now this is classwork, so students, I'm sure you're taking notes on this on your classwork sheet. Rational exponents does not have to form 1 over n. Other rational numbers such as 3 over 2 and negative 1 over 2 can be used as exponents. Two properties of rational exponents are shown below. So rational exponents let a to be to 1 over the nth be the nth root of a, and let m be a positive integer. So we have a to the m over n equals a to the 1 over n to the nth power. And this is the way that you would represent that using a radical. Here, this is really important, students. And then a to the negative m over n equals 1 over m to the nth equals 1 over a to the 1 over n to the nth power equals 1 over a, radical a to the nth index to the nth power. So this is a very formal way of representing this here. This is a breakdown of it, especially with a negative m here, exponent. It puts this down into the denominator here, and this is a further representation of this situation here. Then we move into example 2, evaluate expressions. So rational exponent form. So 16 to the 3 over 2 equals 16 to the 1/2 cubed, which equals 4 cubed, which equals 64. Because the square root of, and then 16 to the 1 over 2 is like the square root of 16 is 4. And then 4 cubed is 64. Then the radical form here, this is rational exponent. And then the radical form here is the radical 16 cubed, because 16 to the 1/2 power is basically this radical here. And then you cube it, and then you get the same thing. Evaluate 32 to the negative 3 to the 5th power. So we just flip it here. We just put it into the denominator, and then we factor out a 3 here. So we cube the 5th root of 32, which is 2, and then 2 cubed is 1 over 8. And this is a rational exponent. Then the radical form is here. We do the same thing here. And then we have 32 to the 5th root cubed. It comes up with the same thing, 1 over 8. Students, this is your guided practice. This is your independent practice down here. You should be able to do that. it up here, evaluate the expression, 4 to the 5 over 2 power. So we factor out a 5 here. Then we have 4 to the square root of 4, which is what? 2 to the 5th power is 32. So anything to the 1/2 power is taking the square root of it. Square root of 4 is 2, and then we take that to the 5th power, which is 32. And then this shows how it's done on a calculator here. Then we go into our homework. Actually, this is homework class. This ain't classwork. Vocab, and then writing, copy and complete, explain how, and then matching expressions here. We match these with this stuff over here. How do you match this over here and then point this wherever you got to go with it? And then here, rewrite the expression using rational exponent notation. So we're taking the cube root of these things, da da da. I'm not going to give it away. And then finding nth roots. Come on, students, jump on this. And then page 6 of your homework, do this here. And then page 7. Evaluate the expression without using a calculator. It's like, oh my God, how can I do this without a calculator? You're going to have to buckle down. These PowerPoints are available either as PowerPoints or videos. Email me, tell me what you want, and I'll give you a price, and I'll give you when I can send it off to you, okay? Bye.